Okay. Rationalizing denominators now. That means we're getting the square root out of the denominator. You need to get the exponents to add to 1. That's the idea. Okay, you can't have root signs on the bottom. You can't. You can't have fractional exponents on the bottom. You can't. Not allowed. So when you're simplifying, when you're rationalizing denominators, you're looking for whatever makes the bottom exponent add up to 1.
I'm Ron Burgundy. You stay classy.
So what that means is, in this example, I have 1 over root 5. Well, root 5 I can rewrite as 5 to the 1/2. Okay, so we're going to multiply the bottom by 5 to the something power. And that something power is going to be whatever happens to make the exponent a whole number on the bottom. Well, I have a half, right? A half is the exponent on the bottom. A half plus what gives you a whole? Well, a half plus a half gives you a whole, which means that's why I'm multiplying by 5 to the half on both the top and the bottom, because now when you're doing that, this is a whole number, because you add the exponents. A half plus a half is a whole, so you end up getting a 5 on the bottom, and you have the 5 to the 1/2 on top, so we end up with 5 to the 1/2 over 5, and we can rewrite that as root 5 over 5. Square root of 2 over the square root of 3. Well, according to our rules, I can rewrite that as the square root of 2 over the square root of 3. Then I can rewrite those roots as 2 to the half over 3 to the half. Well, I need to multiply to get that half out of the bottom. I can't have that fraction there in the bottom. So what can I multiply on the bottom to make that a whole? So a half plus what gives me a whole? A half plus a half. So it'll be 3 to the half that I have to multiply, because a half and a half gives you a whole. So I have to multiply that on both the top and the bottom. So 3 to the half times 3 to the half, I end up getting a whole 3 on the bottom, but they both have a half in them. So basically what that means is I can combine the 2 and the 3, so I get 6 to the half on top over 3, which I can rewrite as root 6 over 3. Example 6. I just separate this by taking the 5th root of the top, so it's x the 5th over the 5th root of the bottom, and when you rewrite that, that is y to the 2/5. Now this one's a little trickier. 2/5. Okay, I need to multiply it by y to the something power. Y to the something power, that will add up to a whole on the bottom. 2/5 plus what gives you a whole? 2/5 plus 3/5 gives you a whole. So I'm going to multiply it by y to the 3/5 on both the top and the bottom. So 2/5 and 3/5 gives me a whole y on the bottom. But now I have that top. I have x the 5th and y to the 3/5. So basically I can take that 5th out of both of them, and I can rewrite it as the 5th root of x and the 5th root of x cubed, or sorry, y cubed. And according to our rules with roots, I can just combine them together underneath that root. So I get the 5th root of xy cubed over y.
Hey, maybe I'll give you a call some.
So a to the 1 over n we can rewrite as the nth root of a. A to the m over m we can rewrite as the nth root of a to the m, or if we wanted to, we could even write that as the nth root of a to the m underneath. It doesn't matter. The big thing here is whatever the denominator is your root. That's your root, right? That's your root. The other number is your exponent, either on the outside or the inside. It doesn't really matter either or.
Richard Gere's a real hero of mine. Sting. Sting would be another person who's a hero.
Okay, so when we're dealing with this problem right here, we're dealing with rewriting these exponents as well. So negative 27 to the 2/3, I could rewrite that as, that is the root. Notice how that's the root, and the squared is on the outside. Now, the reason why I chose this to do it this way is the cube root of negative 27 actually does give us a nice number. Can you think of a number 3 times When you multiply it together, that will give you negative 27. Well, I can. Negative 27 can be written as negative 3 times negative 3 times negative 3. That's why we chose to write it that way. This, if we wanted to, we could rewrite it as the square root of 4 to the negative 5. Remember, whatever's in the bottom happens to be a root. That's why it's a square root. And the reason why I chose the square root here on the inside is the square root of 4. Everyone knows what that is. The square root of 4 is 2. So when we're doing this problem, I really have negative 3 squared, because I just told you the cube root of negative 27 is negative 3. And the square root of 4 is 2. So really, when we're doing this problem, we end up with negative 3 squared over 2 to the 5th. Negative 3 squared is 9, and 2 to the 5th is 32. The reason I'm telling you this is sometimes it's better to rewrite things differently to make the problem easier. If I would have done negative 27 squared and then took the cube root of that, you would still get the same answer, but you wouldn't know off the top of your head what negative 27 squared is. Just like if I was to rewrite this as 4 to the negative 5 and square root that, no one knows what 4 to the negative 5 off the top of their head is, and then the square root of that. So the point is, sometimes you can be picky and you can pick which way you want the order to be to make the problem easier to solve. So with this problem, I'm going to take that third through to everything. So 2 times a third, that is r to the 2/3. 6 times a third, that's s to the 6/3. Well, s to the 6/3, 6/3 can simplify to s squared, and we can now rewrite r to the 2/3. I can take this, put that on the outside, that'll be the cube root of r squared. Remember, this is always your root. Okay, and when we come back here, we will work on this more intense problem here. I just don't want to run out of time in the middle of trying to do the problem.